So yeah, my name is Michał Kopeć. I'm a firmware engineer at FreeNDAP. I primarily work with Coreboot and EDK II, but also Heads and Linux. I'm an enthusiast of open source things. So you might want to ask why EDK2 on ARM? Why even try such a project? So traditionally, ARM platforms have been running U-boot, but with the rise of high-performance ARM SoC like Ampere, Ultra, and others, there is a need for a richer firmware, for more features, for Windows compatibility, for ACPI, and EDK2 can fill that gap. So yeah, there's a lot of communities focused on porting EDK2 to these ARM platforms like Rockchip and MediaTek and Qualcomm. The platform that I worked on was an Odroid M2. It's a small, tiny SBC that has a Rockchip RK3588 SoC. It has a 40-pin GPIO header compatible with Raspberry Pi, an additional 14-pin GPIO header, and the usual connections like HDMI, USB-C, DisplayPort, Ethernet, and interestingly to some, it has a built-in NPU which can be used for inferencing. Out of the box, it runs Ubuntu 25.04 using U-boot. So when I started looking for sources to incorporate into this project, I came across this EDK2 RK3588 repository that has a lot of boards already ported, like Orange Pi 5, Ratsa Rock 5, and more. And I contributed to this repository, adding the Odroid M2 support. So the high-level architecture of the EDK2 port for Odroid M2 is you have a base EDK2 repository, and you have a subfolder with Rockchip platform abstraction layer, which abstracts away GPIO, PWM, and I2C, SPI, and all of that. And you have board-specific code that you have to develop for your board based on schematics and available source code. Yeah. So I took a look at what other boards were doing and how they differed from each other. And the most scary part, I think, is the voltage regulator section of the code, because you don't want any voltage lines to be at the incorrect voltage, because you might damage something, of course. This information about voltages is not present in the schematics, but you can take a look at the Linux source code, and what you find is that there's a exact setting of the voltage regulators there that you can pretty much just copy into your source code and compile. Step 2 was for me was initialization of the PCIe slot. So the board has a PCIe slot for NVMe SSDs. The Orange Pi code I took as a base only had to set one reset signal, but looking at the schematics of the Odroid M2, I had to also enable the power to the slot. So I looked through the schematics. I found out that the reset signal is at the GPIO 1 PA7 and the power enable is at GPIO 0 PC6. And yeah, just translated that into code. You can see how that's configured. And the last part I wanted to get right before booting was PWM control for the fan so that the platform doesn't overheat. I based the code on an existing platform in the EDK II RK3588 repository, but the fan in this board is quite a bit smaller, so I had to configure a lower period and duty duration for the fan, just 50 microseconds. And this allowed me to get the fan to spin quietly and cool the board effectively. As for the other features, USB 2 is fully functional at this point. The onboard LEDs for the status and power are not functional yet. I just have to debug this code and map the correct GPIOs for the power and the status LED. USB 3 is not functional yet either, but works once booted into OS. But it's a bit of a problem because you can't boot anything from USB storage because most USB sticks are USB 3. And booting Windows is also not yet functional because I need to fix the ACPI tables properly. So how do we build? The repository has a build.sh script that accepts just the board as an argument and outputs a flashable bootable image that you can flash to the internal eMMC or to an SD card. I used an SD card for easier swapping of the images. So you just DD the image to the SD card and insert the SD card into the platform and power on. And I have a demo here. Let me just switch the inputs. Oh boy. Okay, can you see the screen?
Yes, but
Okay.
it's like a kind of very blurred, like at least for me, it's like I see the screen, but everything is very low resolution.
Okay, let me just restart the platform then. Yeah, maybe you can see the Orange Pi logo. I haven't replaced that yet either.
Yeah, it is. It's like it is. I don't know. It's like adjusting, but yeah, it changes a little bit in the correct direction. That was better.
It
It's like
looks
I don't know. Is it connection of HDMI or some? This is KV. Now it's good.
uh, looks looks fine on my OBS, so I guess something is
Maybe this is transfer
connection
like flow control of the.
connection issue.
Yeah, sure. I
Yeah,
will
you
have to
can
proceed like that, I guess.
uh, you can see you have the standard EDK II setup menu. We do not have dash arrow features because this is a different code base that hasn't had the dash arrow features integrated. You can see a couple of interesting options. You have Rockchip specific configuration menu. You can configure your displays, display rotation, even CPU performance, PCIe, and USB 5 configuration, USB-C and display ports, USB 3 configuration. You can select which device tree you want to use. In my case, I just have mainline available, but other boards also have other options. You can enable device tree overlays, and you can configure your fan speed and enable the debug CDR port. And then you have standard EDK II settings like RAM disk that we also have integrated into the Sharo, network stack configuration, network device list. All of that is working. And yeah, the platform is booting into Ubuntu just fine from internal eMMC. Should take just a second, I guess. Yeah, there you go. That's your Ubuntu. Okay, so that's it for the demo. And switching back to the presentation. So yeah, what we still need is Windows 10 or Windows 11 compatibility, so ACPI tables, USB 3 mass storage exposed in the UEFI environment, LED status indicators, serial console from UEFI, because that isn't working yet either, and it would be very useful for automated tests, and the full Dosharo release with payload, Dosharo UEFI payload, and feature integration, and the usual testing. And yeah, I submitted a pull request to the EDK II porting, EDK II Archive3588 repository. And a big thanks to the community for providing this repository, and thank you to Hardkernel for selling a board with open schematics, because that's not a guarantee in this world, sadly. Okay, that's it for my talk. If you have any questions, I would be happy to answer them.
Yeah, I wonder about kind of fragmentation of the ecosystem. I'm not sure I understand why there is kind of like separate organization. I don't know if you dive in this and you some have knowledge about why there is a complete separate community with some separate code and they just not working with Linaro EDK2 people.
To be honest, I don't know. Maybe the code isn't that polished yet to be integrated into EDK2 platforms. Maybe the folks in that group aren't fond of the core. I'm not quite sure why that is.
Yeah, what I see on EDK2 platforms and related repositories is that like Linaro is kind of recently like is very active and work very hard on improving quality, even like straight refuse. Like essentially, they took over the maintainership. Like they really seriously took over the maintainership, and kind of sometimes even refuse merging some changes or demand change in the older changes related to, like for example, AMD or ARM related stuff. Before something new can be introduced. So I saw like Asus probably and some other stuff like I guess ASRock also EDK2 platform or maybe this was porting. No, porting is porting is this Renegade project organization. I don't know. So this was Diana Core EDK2 platforms. Yeah, that one. And there's a lot of activity here right now. There's this ASRock Ultra, 24 open PRs. There is also ARM contributing here, Ampere. So yeah. So from the complexity perspective, like, do you have any kind of opinions about, like, let's say, like if we compare what we have right now in Dosharo Core Boot plus UEFI versus on x86 Intel versus what it will take for ARM? Do we see any difference or any immediate roadblocks, problems, difference in maintenance?
So the ports seemed quite easy to get working, surprisingly so, I guess. So maybe the complexity is a bit lower than with Core Boot plus EDK2. or with x86 in general, I should say.
I guess that's part of that is size of the board, yeah, size, because that's very tiny board. Yeah.
Yeah, size of the board and the complexity of the SoC itself. I guess it's a simpler SoC.
Okay, I wonder about leveraging various features, like so some like running some suite that can prove. Yeah, so how you will like do we have a ready software for proving all those features of this SoC?
Not really. Not sure, actually.
Yeah, because I wonder about completeness of the initialization. I guess we will have to run some validation, yeah, like agree on the scope of the validation.
Just test practically on the OSs and the firmware, and yeah, just test.
Maybe some performance comparison also. Yeah, so definitely we plan to continue work on that. What else? Like I'm thinking about, like, definitely, like there is idea of delivering sovereign boot. So I just wondering, like, so how like UEFI runtime services will work on that? This have to be some trust zone. I don't know.
I believe this is implemented using ARM Trust Zone.
So is it is EDK already? Like, I guess they should have already support for that. They have to have support for that because they support other ARM platforms, and essentially UEFI specification take into consideration ARM.